Okay, so chapter 13, exercise 6. This is where these exercises for this chapter are gonna start getting a little bit more complicated. Not because of the things that we're doing with the class or with creating the methods inside of the class. That doesn't get any more complicated. But these methods that we're going to be creating are a little bit more complicated than simply finding the area of this rectangle, or finding the perimeter, or getting the width or the height of the rectangle. Those were very simple, whereas these methods we're going to be creating in 6, 7, and 8 are going to be quite a bit more complicated. But the basic value of creating a method inside the rectangle, inside the class, and accessing the state variables of the class are going to be all very similar. Okay, so let's get into it on exercise 6 here. We need to write a method called contains in the rectangle class to see if a point falls within that rectangle. So, for example, a rectangle at 0, 0 with a width of 10 and a height of 5 is going to contain the point 3, 3, because 3, 3 is going to be inside that rectangle, whereas it will not contain the point 3, 7, because 3, 7 would be above the rectangle. It would be about 2 units above the rectangle. I don't know why I say about. It would be exactly 2 units above the rectangle. Similarly, we need to keep in mind that for the purposes of this problem, even though it might not make sense why we would do this, it might not make sense why we would do this, but for the purpose of this problem, we're assuming that the rectangle has open upper bounds on the width and height, which means that 0 is going to be included, but 10 is going to be excluded along the x-axis here for our example rectangle. So basically the left edge of the rectangle and the bottom edge of the rectangle will be included, but the top edge of the rectangle and the right edge of the rectangle will not be included. So if you look here, point 0, 0 returns true. The bottom left corner will return true, but point 3, 5, which is up along this top edge of the right, sorry, is that right? Yes, along the top edge of the rectangle would return false. 4.99 just inside that top edge would return true, but along the top edge would return false. So 3, 5 will return false because it's up here. 10, 0, or 10, 2 as they say up here, 10 and 2 would return false. 10 and 5, the top right corner would return false. In fact, even 0, 5 up here in the top left corner would return false. So anything that's along this top and right edges returns false. Anything along this bottom and left edges returns true. So it doesn't really make sense why we would do that, right? Surely there's no difference between the bottom left hand and the bottom left corners and the top right corners. But for the purposes of this problem, that's what we've been asked to do. So we're going to do it. So the first thing we want to do is copy down our rectangle class and then get our function definition going. So I already forgot what this was called. Contains. Contains, and we know it's going to take self as an argument, and it's going to take a point. So I'm going to call it my test point, or test P for short. Okay, so now let's think about what this function needs to do. We need to check whether a point is inside rectangle. So we need to do that, and that includes a couple of subchecks. We need to check whether or not the x and y puts it inside the rectangle. So is x value good? And is y value good? And if the x value is good and the y value is good, then we should have a valid point. So if that is the case, we'll just return true at the bottom here. Now, if either of these x or y values is wrong, we're going to return false for them. So we don't have to worry about it getting down to the bottom and returning true on accident. So let's do these. So how would we write an if statement to check if the x value is good? So I'm going to move this up top here. How would we write an if statement to check if the x value is good? Well, what do we know about the rectangle's x values? We know that the rectangle has a bottom left corner, right? So if I call self.corner, which is what I have defined as my point for the rectangle class here, if I call self.corner dot get x, I should be able to get the corner's x value, which theoretically should give me the entire left side of my the value. Sorry, the entire left side of my rectangle. So where my left edge on my rectangle is going to be that all along that x value. Okay, so we can set that to an easier variable so we can access that in just a second. So we'll call that left edge equals that number. So if the test point's x value is less than the left edge, so if it is beyond our left edge this way, then obviously we should return false, right? So that's good. We can return false in that case. But there is also another x value we need to check for, which is whether or not the test point's x value is outside of our right edge. Well, how do we get our right edge? Well, our right edge is going to be our left edge, the x value for our left edge, plus our width. So if the test point x is less than the left edge, or the test point's x is greater than or equal to, let me make sure that I'm writing these function names correctly, is greater than or equal to our right edge, because we want to, remember, exclude the right edge of our triangle. So our example triangle is 10 wide, so the right edge would be 10, so a point that has an x of 10 would be along the right edge, so we want to exclude that. So if test x is less than the left edge, or test x is greater than or equal to the right edge, we want to return false. And similarly, we want to do the same thing for our y value. So is the y value good? I'll go ahead and copy those out. Is the y value good? Well, to do the y value, we need to do a very similar thing. We need to do test p get y, and if that is less than our bottom edge, or test p get y if that is greater than or equal to our top edge, then we just return false. And then if it's not, if both are good, return true. Okay, so this isn't going to work immediately, even though the logic is sound. It's not going to work immediately because we haven't defined bottom edge or top edge yet. So let's do that. Bottom edge, like left edge, is just going to be the y value of our corner point. And then top edge, similarly to right edge, is going to be the bottom edge's y coordinate plus our height. All right, so there we go. This should work. So we haven't tested along the way to see if it works or not. So I'm going to save our code, cross our fingers, and hope for passes. Awesome, passes all along. So you can see it was a little bit more complicated, exercise number 6 here, a little bit harder from the logic standpoint, but we broke it down into a couple of easy steps along the way and tackled each of those steps in succession, which is what we need to do with these harder algorithms that we work on. So break it down into smaller pieces, the smallest pieces you can, and then take care of those smaller pieces individually, and almost 100% of the time you'll find out that it works for you. Awesome. So let's head on to these next problems in the next video.